Welcome back to the deep dive. Today, we're aiming to give you that shortcut, to being really well informed. We're going to unlock some pretty fascinating bits of knowledge. Our deep dive today is all about getting down to the fundamentals of Tableau. We'll be exploring key concepts, things that are just essential, especially if you're maybe looking at that Salesforce Certified Tableau Desktop Foundations exam.
That's exactly right. And our source materials, it's actually a set of practice questions and their explanations straight from that Foundations exam prep. It's a great way to really focus on those core functions, not just what they are, but why they actually matter in practice.
Yeah, good point. And just quickly, for context on the exam itself, it's web-based. You get 60 minutes, 45 questions, you need 70% to pass, and it's multiple choice, multiple select format. So whether you're prepping for that test or just really want to get a solid grip on Tableau's core, well, you're definitely in the right place. Okay, let's unpack this. Where do we start? How about right at the beginning, connecting to data?
Yeah, absolutely. It all starts there with your data connection strategy. When you bring data into Tableau, you've got this pretty critical choice right away about how that connection works.
Okay, so let's say I need something static, like a snapshot of my data that won't change, maybe for performance reasons, or I need to work totally offline. What kind of connection is that?
Okay. For that, you're definitely looking for an extract connection. An extract, well, it does exactly what you said. It takes a static snapshot, and it stores it locally, usually in a compressed format.
Compressed, so that helps with speed.
Exactly. It makes querying much faster, and it's perfect if you need to work offline without hitting the original source.
Right.
Think of it like a saved copy of your data at one specific point in time.
Right. That makes total sense, especially if you've got huge data sets or maybe a slow network connection. So what's the flip side? What's the alternative to an extract?
The alternative is a live connection. And just like the name suggests, a live connection queries the data source directly, in real time.
So it's always showing the very latest data.
Precisely. Every time you interact with the view, it goes back to the source. The practical implication for you, the user, is really this trade-off. Do you need absolute up-to-the-second freshness, or is performance and offline access more critical?
So live for real-time needs, extract for performance, stability, offline use. Kind of depends on the situation.
Exactly. It's about balancing those needs.
Okay, so we're connected. Now, what if my data isn't all in one nice table? Like maybe I have monthly sales reports, January, February, March, separate files or tables. How do I stack those on top of each other?
Yes. For that kind of vertical stacking, you'll use a union. A union is specifically designed to append rows from different tables. It stacks them vertically, one after the other.
As long as they match up.
Right, that's the key condition. They need to have the same columns, the same structure for the union to work properly. That monthly sales report example is perfect. A union consolidates them into one long, continuous data set.
Okay, so union means stacking rows vertically. How is that different from a join? Because joins also combine data, right?
Good question. That's a really common point of confusion, actually. Unions append rows vertically. Joins combine tables horizontally, side by side.
Horizontally, like adding more column.
Exactly. You use a join when you want to add more information about existing rows. For instance, joining customer details to your sales data based on a customer ID. You're adding columns, enriching the rows you already have.
Whereas unions add more rows.
Precisely. Unions add more rows of the same type of information. Unions consolidate, joins enrich. Big difference.
That clears it up nicely. Okay, speaking of combining data in potentially confusing ways, Tableau has this concept of relationships. It feels a bit different from traditional joins. What exactly is a relationship defining in Tableau?
Yeah, relationships are a newer, more flexible approach.
Sure.
A relationship defines a logical connection between tables. And the really interesting part is it maintains the row-level detail of each table without physically merging them together up front like a join does.
Right, so it doesn't actually create one big, potentially massive table behind the scenes immediately.
No, not like a traditional join. That's the beauty of it. Relationships offer flexibility. Tableau figures out how to bring the data together based on the fields you use in your specific visualization at query time.
So it's more on demand.
Exactly. It preserves the original tables and their level of detail, which avoids issues like row duplication you sometimes get with joins. It makes data modeling much more flexible and often more performant, especially with complex schemas. Less rigid,
I can definitely see the advantage there, especially if your analysis needs change. Less upfront commitment. Okay, so we've combined data, but raw data often needs organizing. How do we create those nice drill-down paths in Tableau, like going from region to state to city? What are hierarchies built from?
Right, for creating those drillable hierarchies, you mainly use dimensions and groups. Dimensions are your typical categorical fields like text or dates, like region, product category, order date.
Okay.
And groups. Groups are basically custom collections you create from dimension members. Like you could group certain states together into a West Coast group, for example.
And why not? Measures or parameters, can't use those.
No, not for hierarchies. Measures are your numbers. Sales, profit, quantity things you aggregate. They don't represent levels you drill through. And parameters are like user inputs, variables that let someone change a value in the view, like selecting a top end or a benchmark value. They aren't part of the data's inherent structure.
So dimensions and groups are the building blocks for letting users navigate from high-level summaries down to the nitty-gritty details.
Exactly. It makes exploration much more intuitive.
Got it. Now, another really fundamental concept. Discrete versus continuous fields. Blue pills versus green pills. What really defines a discrete field? Why does that difference matter so much?
Discrete versus continuous. Super important. Discrete fields treat data as, well, distinct separate items. Finite. Think individual categories like product types or customer names. They typically create headers or labels in your view.
Individual buckets, kinda.
Yeah, exactly. And they're often used to assign distinct colors or labels to marks on a chart.
Okay, and continuous.
Continuous fields treat data as forming an unbroken range. Think numerical axes, like sales from 0 up to millions, or a date axis flowing smoothly over time. They create continuous axes in your visualizations.
So discrete gives separate items, continuous gives a spectrum, and this impacts how things look.
Hugely. It fundamentally changes how Tableau draws your charts. Discrete fields often give you headers and distinct sections. Continuous fields give you axes. The color legends work differently too. Discrete fields get distinct colors per item. Continuous fields get color gradients. Getting this right is key to building the viz you actually intend to build.
It definitely sounds foundational.
Good.
Okay, shifting to aggregation. When I drag a measure, like sales, onto a view in Tableau, what does it do by default? How does it aggregate those numbers?
Good question. The default aggregation for measures in Tableau is SUM. It'll automatically add up all the values for that measure in the context of your view.
Just sums everything up.
Yep. Unless you specifically right-click and choose something else, like average, median, count, or count distinct, it defaults to SUM.
Right. I think everyone runs into that at some point. You want an average, you drag the field, and the number looks huge because it's the total sum.
Yes, that's a classic beginner mistake. Or will even experienced users forget sometimes. You drag sales expecting maybe an average sale price, and you get the grand total. It's subtle but critical. Always double-check that aggregation setting, especially when you first build a view.
Definitely a key takeaway. Okay, visualization choice. Let's paint the scenario. I want to compare sales across different product categories and their subcategories all in one chart. I need to see the hierarchy and how much each part contributes. What chart type is best?
Okay, for that kind of hierarchical comparison where you also want to see the proportion of the whole, a tree map is usually the best choice.
A tree map. How does that work?
Tree maps use nested rectangles. The size of each rectangle represents a measure like your sales total. And these rectangles are grouped and nested based on your categories and subcategories. So you can easily see, say, the technology category, and within that, the phones subcategory, and how big its sales are relative to everything else.
So the nesting shows the hierarchy and the size shows the proportion. Makes sense. Why wouldn't something like a heat map or maybe a simple bar chart work as well?
Well, a heat map uses color intensity, usually across 2 dimensions, more for spotting patterns or concentrations. It doesn't inherently show hierarchical proportion like a tree map. And while you could use bar charts, maybe grouped or stacked, representing multiple levels of hierarchy and proportion clearly in a single bar chart, can get visually cluttered really fast. The tree map is purpose-built for this, parts of a whole hierarchical view.
Gotcha. Choosing the right tool for the job. Crucial for making the data easy to understand.
Absolutely. It's all about clear communication.
Now, let's make things interactive. We build a dashboard, but we don't want it to just sit there. How do we add interactivity, let users explore?
The main way to add that kind of dynamic exploration is using dashboard actions. Actions let you set up interactions between different sheets on your dashboard.
Like clicking on one chart filters another.
Exactly. That's a filter action. You can also set up highlight actions, where selecting something in one view highlights related marks in other views, or URL actions, where clicking a mark can take the user to an external web page, maybe with more details.
So actions are the key to turning a static picture into something people can actually interact with and investigate further.
Yes, Precisely. They make dashboards much more engaging and powerful. Users can follow their own questions, which often leads to deeper insights than just looking at a fixed report.
That sounds much more useful for the end user.
Okay, related to user experience. What if I have several different views or charts I want to show, but I don't want to cram them all onto one dashboard, and I don't want to create totally separate dashboards? Is there a way to let users switch between views within one dashboard space?
Yes, there is a clever way to do that. You can use what's often called a sheet selector. This usually involves a parameter and a calculated field that controls which sheet is displayed in a specific layout container on the dashboard.
So the user picks an option from, say, a dropdown.
Right, they pick view A or view B from a parameter control.
And the main area of the dashboard swaps out the corresponding sheet.
Exactly. It lets you effectively overlay multiple different visualizations in the same dashboard space, allowing the user to choose which one they want to see at any given moment.
That sounds incredibly efficient for saving space and keeping things tidy.
It really is. It's a great technique for packing a lot of information into one dashboard without making it feel cluttered or overwhelming. Streamlines the experience. Nice tip. Okay, last area. Filtering. Specifically, continuous fields like dates. If I want to give the user a filter for a date field, and I want them to be able to pick a specific start date and a specific end date, a custom range, what's the filter option for that?
For letting a user define a custom start and end date on a continuous date field, you'll want to use the range of dates filter option. That presents the user with typically 2 date pickers or sliders where they can set the exact beginning and end of the period they're interested in.
So that's different from like a relative date filter.
Yes. Relative date is for dynamic ranges like last 7 days, previous quarter, year to date. Those adjust automatically based on today's date.
Or different from just picking specific dates from a list.
Right. That would usually be a multiple values list or multiple values drop-down filter, typically used more for discrete dates or other discrete fields. The range of dates is specifically for selecting that continuous span between 2 points in time.
Got it. Precise filtering is key for letting people zero in on what they need to see.
Absolutely. Targeted analysis depends on good filtering options.
So maybe the final thought for everyone listening is this. How does really grasping these core Tableau behaviors, understanding things like default aggregations, connection types, discrete versus continuous, how does that empower you to move beyond just seeing your data to actually shaping the story it tells?